Hi, it's Mike Stevenson here. So in the video today, we're going to have a look at part two of the video I was doing about developing consumption logic apps with Terraform. So in the previous video, we had a look at this PowerShell script to download your workflows from the Azure portal that you would be developing, and then we looked at some of these files down here where we can sort of point to that workflow JSON, redeploy our logic app, have it inject in parameters and that kind of thing. Now, what I wanted to also look at is we saw in the workflow previously over here, we had logic apps, calling, API management, SQL functions, etc., etc. And I wanted to talk a little bit about how that gets handled in the Terraform approach. So here we've got a file, this connectors.servicebus. So if I want to create a service bus connection, I can use this AZ API resource from Terraform, and I just specify that I want to use these web connections, and then I can specify things like the name and the location and the parent ID. And then what I can also do is, like before, we were injecting in some tags, so I can provide the appropriate tags that I need for my resource. And then what you need to do after that is specify the body. So here I'm doing a JSON encode function in Terraform where I can just supply the JSON for it here. And what I can do is I can point to the service bus connector. So if you see over here, we've got the managed APIs and service bus, and I can inject in the subscription that I'm using in my Terraform solution. And then I can also indicate, it's a managed API, but the only value I really need for once I've got it set up is this connection string. So here, if you look, what I'm doing is, because we talked in the previous video about these data objects being able to reference the resources, and also I can create my own resources. So I've got my service bus up here, but I can also create a queue. So while I have a pointer to my existing service bus, I know that in my solution here I need a queue. So what I can do is that up here I can say, right, let's go and create a queue called demo logic app 1, and then I can also create an authorization rule for that queue. So you can see here I'm saying I've got to send and listen but no manage, and it only applies to that particular queue. I can add this the connection string. I can add it to key vault if I want, for example, down here, so I can manage an individual key vault secret from my solution. But then if I go back to my service bus connector over here, what I'm doing when I specify this value here is I'm kind of saying, go to my service bus queues authorization rule. I may have multiple of them, so you would specify the key for the one you want. So I'm saying, find the rule for my demo 1 queue, grab its connection string, and that'll be the value for the connector when I deploy it. So I'm kind of, if you think of the equivalent of the ARM template, this is where you would be injected in parameters from various things. But here, it's quite easy to point to the other objects that I'm creating. So I'm creating a service bus, then I'm creating a connector that'll point to service bus. I'm injecting its connection string, and then when I deploy my logic app, I'll be pointing to this connector. So likewise in the logic app, we also have the SQL connector. So here I've got a very similar thing where I've just got a local variable to specify my connector name. I'm passing that here to give the connector its name. I'm pointing to other objects here for the resource group that I'm going to deploy it into. And then the same as before down here, I'm specifying which API I want. So I want the SQL one. And then I'm passing in these parameter values. So you can see here, I've got I haven't got the SQL database in this Terraform solution, but I've got a key vault which already has secrets in it for pointing to the database. So I've got this example database in a Synapse demo I've done previously. So I'm grabbing the keys from Key Vault for the server database, username, password, and that'll configure this SQL connector and deploy it out. And if we have a look over in the resource group here, you'll see this is my connection here. point into my SQL database, and we're all good to go. Now, the so you can see once you get used to this, it's actually pretty straightforward to set up a connector. You just need to know which connector it is, know how to set the values. Now, if you could probably start off by creating one in the portal, pull it into your Terraform solution. There's a couple of different ways you might do it, but it's quite easy to set this up, and it's a lot more readable than what the ARM template would be for the connectors, and to understand the relationships, I think, and being able to pass these parameter values as well, because here I'm just referencing them from the key vault that I've got a data reference to up here. So I've said, here's my key vaults resource group, here's my key vault, and then I've got a bunch of secrets in that key vault that I can reference, and that'll pass the values in at deployment time. So the next thing we had was, if we go back to my logic app, this demo one, so we had a helper function. So I've covered the database one, I've covered the service bus. In fact, let's do API management next. So up here we've got my API management, where I had a helper API defined. So if you imagine in another solution somewhere, I've deployed API management and I've set this helper API up. Now, what if you imagine in consumption, I might have 10 or 15 different logic app solutions. Occasionally, I might want a helper API for that logic app that does something that only that logic app needs. So you've got two approaches here. You can have a centralized solution for that API, and you can go and add to it, deploy it, and then reference it. Or the other option that I'm doing here is I've got I've got this file here, this APIM helpers. So I want to add a helper to the existing API. So here I'm defining an operation. I give it a name. I tell it which APIM I want to deploy it to, and then I basically just say go and deploy that API. Here's the URL for it, etc. And then down here I'm specifying a policy for it, and here I tell the policy, when you deploy the policy, here's the operation that I want to put it onto. So you can see this value here matches this value up here, so it knows which operation to apply it to. And then in my operation here, I'm going to validate a JWT token, so I can specify things like the tenant ID I can take from my Terraform context here. So you've got this Azure AD client config. And then if my token's valid, I'm going to return a response with just the settings of that token in it, so I can have a look what the token looks like, and I've got an error policy down at the bottom there. So when I deploy it, this will go and update that API operation, and then I'll be able to reference it in my logic app. So you can see here, I'm able to call it, and actually I'm using the managed identity that I've got set up, and I'm passing the audience to it. So when I run it, it's kind of wired these things all together in my solution. Next up, we've got the function. Now, what's interesting about the function is, there's a couple of different ways you can build functions. And what I've done here is I want to have an inline C# function. So let's imagine I've got a logic app. I want to write a few lines of C# code to do something really simple. I don't want to have to worry about building an entire .NET project and all the DevOps that goes with it, because there's definitely cases you would want that. But if I've just got this one logic app that needs a little function to do something that's a bit too complicated to do in an inline JavaScript or something like that, what I can do is I can use this reference to my existing function app that I've got that supports CSX files for inline functions. So back over here, I've got this CSX file. I've got a simple function here that it's really just the sample one you get in the portal. So I've got a bit of C# code that I can write, maybe you develop it in .fiddle or VS Code or whatever. And all it's going to do is just, in this case, return a response. And in my Terraform, I can then create this resource called Azure function Azure APIM function app function, and it's basically going to take that CSX file that I've got here. So you can see we've got a reference to the file here, and I'm going to use that when I run this Terraform. It'll basically add that file to the function, and then I'll be able to call it from my logic app. So you can see we're just saying this is the function app to use, so it points to our Terraform data object here. I've given it a name. I've told it what C# code to deploy as this file. I've got an example message I'm putting in and stuff, and I've configured my bindings, and it'll just deploy that function for me. Now in my logic app here, so you can see I've got the function call set up there, but the challenge I've got is when I deploy my logic app. So you can see up here we're specifying things like the resource script for the function. So when I run my PowerShell that downloads the workflow JSON, one of the things that I did was I just look for any function apps that I've got and just do a parameterize of the function value here. So I've looked for my function app name, and I've just basically parameterized that there. So that means my workflow JSON here will have that. So let's see if we can find the function. There we go. So we've got functions, resource group, and helper function app name and subscription. So you can see that function ID is being parameterized. And when we do the deploy from Terraform, we're just injecting the deployment time parameters. So this would, I wouldn't even need to set up all the variables or anything in a DevOps pipeline. By running the Terraform, it should be pointing to all my common resources, and therefore it'll just know which ones they are and which values to use at deployment time. And then it's going to just inject that function's resource group and function app name here, because I've got a pointer to that function app. So when the logic app deploys, it'll already have the right value in, and that'll work in my DevOps pipelines quite nicely. So where we are now is, if you imagine I've got this Azure integration solution I'm building in Terraform, I'm able to build APIs, I can build service bus queues, I can build connectors, I can handle logic apps all in the same solution, deploying with the same Terraform code, and I've kind of minimized the skill sets that I need to have from being, C# over here and APIM over there and all that. I've kind of rationalized it to be just configuration, infrastructure as code with Terraform that I can deploy all in one hit. And hopefully that gives you the idea of an Azure integration solution, which starts making these consumption logic apps a little bit easier, because I think in the real world, it's easy to knock up a logic app and deploy it, but it gets harder when you say, right, well, now I've got my connectors, now I've got a queue and an API, a function, etc. And you end up having different solutions for each one. And there's a balance where sometimes that works really well, particularly for common functions and common APIs, but those times where you just need some little something specific for that logic app, here's a way you can do it, and that works quite well. So we'll get all this sample onto GitHub so people can have a look and try it out, and hopefully it'll help people out a bit and just give a way to simplify things a little bit.